Okay, so we are going to be doing a very short lesson. It's a very simple lesson. I think you'll like it because of that. And it's on what we call first differences, which you actually have already done. It's just that we have so many different names for first differences. So if you could go back and look at the example that we did last time, we did this together in a presentation, and it was about Susan having a dog sitting service. She charges the basic fee of $10 and $4 an hour. And what we did is, we put in the number of hours she worked and how much she would charge. Notice that she's charging a $10 flat rate just for showing up and grabbing your dog, okay? We also talked about the rate of change. So what the rate of change was how we get from, as we go up by one each time, how much are we going up by? So every hour, we're going up by the same amount, which was 4. And if we go down here, and we found, if we were over here and we were talking about finding the slope, and we did, let's say, 2 points here, we knew the rise, and we talked about this already, every square was worth 2, so the rise was 4, and it was a fee for $4. And that was, over a period of 1 hour. So if we went down here, the slope of the line was $4, and it represents $4 per hour, or her hourly rate. Okay. Now, the key to this one is, if we see that it goes up by 4 as we're going up by a consistent amount here, we realize that the slope of this line has to remain constant. It has to, for every hour, it has to go up 4. Another hour, up 4, okay? If all of a sudden she charged more, you'd be flying up like this. Or if she charged less, you'd be going a lot less steep. And then it wouldn't be a line anymore. Yes, okay? So, first differences, go back here, is actually the exact same as what we call a rate of change, and it's also known as the slope of a line if we do it exactly every time we go up by 1. What are we going up by on the other side? Okay, so first differences might also be called rate of change, might also be called the slope of a line. The only important thing about it is that if your first differences remains constant, you can state it's a line no matter what. So all we're going to do is look at a few examples, and I'm going to put this down. I'm going to throw up my actual big note. All right. And we're going to talk about, if I find my, alright. Can you tell if a function, a relationship, is a linear relationship just by looking at its table of values? Okay, so it's very simple. You're going to draw in a third column, and you can call this first differences. You can call this a rate of change. It does not matter. It's the exact same thing. So first thing you want to check is, what are we going up by? Is it the same amount each time? Yes, we're going up by 1 each time as we go up. So then, what are we going up by on this side? Is it also the same amount each time? And look at that. So that one, yes, is a linear relationship. And that's pretty much all we're going to cover today. We're going to do one extra little bit at the end, but that's pretty much the idea. Okay, so got a few more. If you want to take the time to write these down, go ahead. Okay, so this one, we're going up every time we go up by 2 in our independent variable, okay? We are going up by 10 over here. So yes, as we go up by a constant x value, our y values are going up by a constant amount. If you wanted to graph these, you would see it was a line, but this is so much less work, and we don't like to spend more time doing things than we have to. I think we all can agree with that. So this one is linear, this one is linear, this one, okay, going up by 1, going up by 1, and so on. I can see that that's occurring. And this one, I'm going to be going up by, oh boy, -1, 1, 3, 5. Okay, so I do not have a constant rate of change or first differences. So all you have to know is that that is not linear, okay? It is a non-linear relationship because that's not constant. Okay, one last one. Again, actually, I'm gonna make this, let's see if I can do this. I'm gonna change this up a little bit because I didn't do any of these and I should have. Okay, so we're gonna make those negative. As we go up by 2 on this side, we are going down by 3 on this side, okay? So, constant rate of going up on the x's, you have to make sure that. Is the first differences also constant? Yes, it is. This is linear. It doesn't matter if it's positive or negative, it just matters if it's constant, okay? So that's just the basic rule there. Now, another step to this, which is an important thing to be able to do, but it's just an added on bonus, is to find the slope of the line from this. Because we said first difference is rate of change, but this is not necessarily equal to the slope of the line because we aren't necessarily going up by ones. So in this case, and again, if you think about this, I'll put a little thing here, okay? Here's your x's, and here's your y's. Every time you go up by 1, this direction, you're going up by 3 in that direction. So in actuality, I'm trying to think, you're gonna have a line that goes like this, okay? So this x value is your run, and the y value is your rise. And if you want, you can graph this to confirm it, okay? So in this case, the slope of the line, for every time we run 1, rise over run. So every time we run 1, we are rising by 3. So our slope for this line is 3, okay? Same thing here, run and the rise, except in this case, when I'm doing this one, I'm going up by 2. So every time I jump 2 in the x direction, I go up by 10 in the y direction. So in this case, my rise over my run, the slope of the line isn't going to be 10, it's going to be 10 units per 2 units, where you rise 10 every 2. That's a slope of 5. Okay? This one doesn't have a slope. You're going to learn about these in grade 10. These are quadratics. You don't have to do anything other than to know they are non-linear, and you're done. And for this one last little thing. If we were to figure out the rise over the run in this case, for every time we run 2 units, we go down 3. So our slope for this case is going to be -3 over 2. Okay? So slopes can be negative, they can be fractions. Not something that you're going to have a direct question on right away, but definitely a concept that you're going to need to know for grade 10. Okay? So I'm going to assign some homework questions out of the textbook, but really all you're going to do is check that these are going up by the same amount each time, and then figure out if these are, and therefore if it's linear or not.